I wanted to finish up the homework for Learning Target 1. The reason I'm choosing a new video is just because they're completely different types of problems. These problems are actually trinomials, and you have factored these before. But one thing you ought to know is this pattern called the difference of two squares. And this was one of your vocab terms from the last unit. Squares are when you square something, just like in the last video. Cubes are when you cube something. So difference means subtract, and two squares means you're squaring something. So a squared minus b squared. Difference of two squares. Whenever you have that, you can factor it into a plus b times a minus b. Okay, let me just give you a quick example of that because this is really easy. For instance, if I had x squared minus 16, those are both perfect squares. So the square root of x squared is x, and the square root of 16 is 4. So x plus 4, x minus 4. Okay, very simple. Do one more. 4x squared minus 100. Okay, well, those are both perfect squares, so I have 2x plus 10 and 2x minus 10. Okay, pretty simple. So the rest of this homework was numbers 9 through 14. So let's start with number 9. Okay, and that's x to the 4th minus 5x squared plus 4. Okay, the only difference between this and when you factored quadratics before is now instead of x squared and then x, you have x to the 4th and then x squared. So when you factor it, you start with your two groups of parentheses, and instead of putting x and x like you've done before, you'll put x squared, because if you were to FOIL this, you want these two terms to multiply to be x to the 4th. So that's why you get x squared and x squared. Okay, now the next two numbers, if you remember, it means they have to have a product of this, okay, meaning they multiply to be 4, and they have to have a sum of negative 5. So your first thought needs to be, well, if they multiply to be positive, they're going to have the same signs, either plus plus or minus minus. Okay, but since they add to be negative, we know the two signs are minus minus. Okay, and what two numbers multiply to be 4 but combine to be 5? Well, 1 times 4. Okay, so now if you just kind of self-check this, negative 1 times negative 4 is positive 4, and negative 1 plus negative 4 is negative 5. Okay, and now I could actually factor this even further because what we have here is the difference of two squares. Okay, so I could actually factor this into x plus 1, x minus 1, and then the other one is also difference of two squares, x plus 2, x minus 2. So this right here is the completely factored form of that polynomial. And now to finish solving, if I use the zero product property, I get x equals negative 1, positive 1, negative 2, and positive 2. Okay, so there's all of my solutions for number 9. So the rest of these problems are very similar to that. If we look at number 10, again we start with the x to the 4th minus 12x squared plus 11. Okay, this is almost just like the last problem. But when we factor it, we're not going to get the difference of two squares on both factors. But again, if they multiply to be positive 11, but add to be negative 12, that's going to be minus minus. And 11 only has two factors, one in itself, so it has to be this. Okay, and it is because negative 1 and negative 11 combine to be negative 12. I wanted to show you a different way that you could actually finish solving this. If I were to set both factors equal to 0, which is using the zero product property, on this first one I would add 1 to both sides and I would get x squared equals 1. Now to finish solving, you have to take the square root of both sides. But don't forget, when you solve by taking the square root, it's plus or minus. Okay? Over here, if I add 11, I get this. And when I take the square root of both sides, well, you can't simplify the square root of 11. So you leave it square root of 11. But when I solve by taking square roots, plus or minus out in front. So these are the four solutions. 1, negative 1, square root of 11, and negative square root of 11. On to number 11. Okay. X to the fourth minus 10x squared plus 16 equals 0. When I go to solve this, just like in all the other ones, x squared, if they multiply to be positive but add to be negative, it's negative negative. So what two numbers multiply to be 16 but combine to be 10? Very good. 2 and 8. So 2 times 8 is 16, and negative 2 and negative 8 give me negative 10. Okay, if I set both factors equal to 0 and solve, I'll end up with x squared equals 2 by adding 2 to 0. And if I add 8 to 0, I get x squared equals 8. When I solve by taking square roots, don't forget to do plus or minus. The square root of 2 doesn't simplify, so it stays square root of 2. However, when I take the square root of 8, it actually does simplify. Still do plus or minus, but I get 2 square root of 2. And let me explain why. Okay? Square root of 8. It has a perfect square factor. I can actually factor into the square root of 4 times square root of 2. And what's the square root of 4? 2. And the square root of 2 does not simplify, so I leave it as such. So you can see here that these are my 4 answers. Moving on. Number 12. Number 12 actually has some solutions that have a multiplicity. Because this is actually a perfect square trinomial. But if I were to factor this like I've done all the others, start with my x squared and x squared. They multiply to be positive but add to be negative, so it's negative negative. Two numbers that multiply to be 16 and combine to be 8, that's 4 and 4. So you'll notice I get the exact same thing here. So when I go to set these equal to 0 and solve, I get x squared equals 4, x squared equals 4. When I take the square root, I get plus or minus 2 on both sides. Okay? So really, my answers are 2 and negative 2, both having a multiplicity of 2. So the way I would write that is x equals 2 with a multiplicity of 2, and then negative 2 with a multiplicity of 2. Okay, and I'm just abbreviating multiplicity. Okay. 2 more. Number 13. It's x to the 4th minus 9x squared plus 14 equals 0. Alright. Start with x squared, x squared. If they multiply to be positive but add to be negative, it has to be negative, negative. Two numbers that multiply to be 14 and combine to be 9, that's 2 and 7. If I solve using the zero product property, I would add 2 to 0 and get this. Using the other factor, I would add 7 to 0. When I take the square root of both sides, neither one of these square roots simplify. So I'd leave that plus or minus square root of 2 and plus or minus square root of 7. These are my 4 answers on number 13. And then finally, number 14. X to the 4th plus 13x squared plus 36 equals 0. Now this one's going to be slightly different than all the others, because all the others we've done, they multiplied to be positive but added to be negative. Now, this one has two numbers that multiply to be positive, but they also add to be positive, meaning plus and plus. So we need two numbers that multiply to be 36, but combine to be 13. And if you think about it, it's 4 and 9. Okay? Now here's where this one's a little different. When I go to solve, I would actually subtract 4 from 0 and I get negative 4. And on this one I would get negative 9. And when I take the square root of a negative, don't forget that you actually have to take out the I. So it would be I square root of 4. But the square root of 4 simplifies. So I would get plus or minus 2I for this one. Over here, when I take the square root, plus or minus I square root of 9, and then the square root of 9 is 3, so I get plus or minus 3I. And these are my 4 answers here. See, here I actually get imaginary answers. And that is your day 4 homework. Make sure you understand these. Go back and watch the rest of the videos and the slides, and pause it where you need to, and email me if you have questions.